and top of the evening to ya, you wee little lads and lassies. That is my poor attempt at a leprechaun. And look, I have a sparkly shamrock because tomorrow is St. Patty's Day, at least from the time I'm recording this. Maybe not when you're watching this, but when I'm recording it, it is. And I feel like this is so appropriate because 2 days ago, it was just this day, Pi Day. So if you don't know, this is the symbol for the Greek letter pi, and we use pi as a mathematical value. So it's a Greek letter, but we also use it to represent the number, which is the ratio. So pi, if you didn't know, is a ratio of the distance around a circle to its diameter. Pi is special because it never ends. Terminates means ends, and it never repeats. Computers have calculated pi to 12 trillion digits. So, extra credit, I will give you an A+ for quarter 4 if you memorize 12 trillion digits of pi and can give it to me. You know what? Since I'm nice, I'm going to make it just 1 million digits. So if you can memorize 1 million digits, I will give you an A+ for the quarter, and you can quote it to me from memory. 12 trillion digits. I know 3.14159. 14159. 5 is all I've memorized. But some quick history of pi, not the kind you eat, but the kind that you will be working with in this section. Ancient Babylonians used triangles to estimate the value of pi, so they got it to 3.125. Egyptians used squares and got 3.16. Ancient Greeks got it between 3 and 1071 and 3 and 1/7. Chinese astronomer estimated the value of pi to this, and then this guy, back in 1737, Leonhard Euler, popularized the use of this pi symbol. So the concept of pi has been around for about 4,000 years, but the symbol has only been around for 300. So when calculating pi, it's the most recognized mathematical constant. Because the first 3 digits are 3.14, March 14th is recognized as Pi Day. Albert Einstein was born on Pi Day in 1879, and you guys know that Harley was born on Pi Day in 2020. But again, pi is about 3.14, and it's the ratio of the circumference to the diameter. So if we take the circumference of the circle, which is the distance around, and divide by the diameter of the circle, for every circle, this circumference divided by the diameter always equals pi. So just a few things about pi, which is good to know. And we are going to look at page 447 in your book. So go to 447 in your books, and this is where we're going to take notes. So first, we're going to look at, in this section, circles. So let's just talk about a circle. You guys all know what a circle looks like. Hopefully you learn that in before you're 1, you start learning shapes and stuff like that. So a circle, though, formal definition, is the set of all points in a plane that are the same distance from a point called the center. So this is the what we call the center of the circle, this point here. And all these green points are the exact same distance from this point. So all the points that are the same distance from this point called the center is what make a circle. The diameter is the distance across a circle through the center. So a line through the center all the way across is called a diameter. And then from the center to any point on the circle is a radius. So there's one radius, but we can have a radius here or here. Oh, that happens to be almost the exact same color. Isn't that cool? So here. So if you think about the spokes on a wheel, each one would be one radius. And the plural of radius is actually radii. So one is a radius, more than one is a radii. And the diameter is twice the length of the radius. Hold on 1 second. Okay. So I think I didn't want that to go yet. Because the radius is the distance from the circle to any point on the circle, the diameter is always twice the radius, or the radius would be half the diameter. So the diameter is 2 times the radius, or the radius would be considered half of the diameter. So the diameter is longer than the radius of the circle. Now go to page 448 and look at page 448. The circumference of a circle, is kind of like perimeter. Like you guys know perimeter, like if we want the perimeter of a square, it's the distance around. The circumference is the same thing but for a circle, so it's like the distance around. Now again, the circumference is proportional to its diameter. This circumference divided by diameter is always pi, 3.1415926. Ooh, I'm going to memorize 2 more digits of pi this year. 3.1415926, 3.1415926, 3.1415926, 3.1415926. We usually just use 3.14, but a lot of your calculators have a pi button that you can use. So you can use 3.14 or you can use the pi button. Another approximation is 22/7. So the formula to find the circumference of a circle, we can multiply pi by its diameter. So basically, if c over d equals pi, then to find the circumference, we can just multiply pi times the diameter. So in symbols, c equals pi times d, or because the diameter is 2 radii, we could say that the circumference is 2 pi times 2r, or the way we write it is like 2 pi r. So circumference of a circle, and this is one you should memorize just because you'll use it a lot in geometry and so on and so forth. Circumference is pi times diameter, or 2 pi r, and that's our formula for the circumference of a circle. So go to page 449, and we're going to look at an example of finding the circumference of a circle. So if we have the diameter, we want to find the circumference, the distance around the circle. So Big Ben is a clock in London, England. The diameter of the clock is 23 feet. What is the circumference of the clock? So again, circumference is pi times diameter. So we'll plug in 23 for the diameter. And then we can replace pi with 3.14, or you can use the pi button on your calculator and get an approximate circumference. So the exact value still keeps pi in the answer. This is an approximate value. So when you leave it as just 23 pi, this is the exact circumference. But when we use an approximation for pi, this is the approximate circumference. So the approximate distance around is about 72.22 feet. By the way, if you didn't notice, here we have equal sign, but then we have these squiggly lines. I don't know if you guys know, I don't know if we've talked about this yet, but when the equal lines are not straight, this means approximately equal to. So it means approximately 72.22. So when it's a squiggly equal sign, that means it's not exactly equal, but about equal to. So you guys do the check problem on the bottom of page 449, and next to it, draw or write what is your favorite type of pi. Not this kind of pi, but this kind of pi. So next to the check problem on the bottom of 449, I'm going to be checking all these things this time to make sure you guys are watching. So what is your favorite flavor of pie? And then you guys can go to page 450, and let's look at the next example here. So we want to find the circumference given the radius. What is the circumference of a circle with a radius of 21.2 inches? So this time we don't have the diameter, so since we have the radius, we'll use this version of the formula, c equals 2 pi r. So again, we know what r equals, so all you have to do is replace r with 21.2. And then I'm going to multiply the 2 and the 21 to get 42.4 pi. So when we multiply these two, this is the exact circumference. But when we replace pi with 3.14, then this is the approximate circumference. So the circumference of a circle is about 133.136, and I got it right. I mean, the answer is right there, so it's not that hard to get it right. So on the check problem on the bottom of, or kind of like the middle of page 450, see if you can find the circumference of that circle, and you're going to give the approximate one. So you, I mean, like if you don't use this symbol for equals, that's fine. If you just use the equal sign, that's totally fine. But just know that that means that it's approximation. And then on the bottom of page 450, we'll stop here for this lesson. On the bottom of page 450, in that box, get a parent to sign. And since it's St. Patty's Day, draw your best 4-leaf, or here's a 3-leaf clover. I don't know, mine's not that great, but I will be checking the the check problems on both pages, as well as those 2 things that I mentioned for credit for this video. And that is all. Until next time.